right. So here's your warm-up for today. If you have not done this yet, you need to pause the video right now and do this warm-up. And if you think you can just get by without not doing it, you'll probably be a little lost in the rest of the notes, because this problem, I'm going to use it again. So you should do this problem right now using the table like we did yesterday. So again, pause the video because I am about to show the answers. So you unpause it when you're ready to see the answers. First part, you're just drawing a little picture there, marking it off. This one says, what percent of adult women do you expect to have cholesterol over 200? There's my notation. Here's my picture here. I went over 200. I found the z-score of 0.5. I looked it up in my table. This is the z-score. It is not an area. So if it's a z-score, I am on the z-score part of the table. So I am out here, although 0.5 is positive. So I am out here, 0.50. That is these numbers in here are the area. So that's the area to the left. I want the area to the right. I do 1 minus that. There's my answer. What percent of adult women do you expect to have cholesterol levels between 150 and 170? Again, I'm finding the z-scores. So those are my two z-scores. There's z-scores. So I'm looking at the z-scores and I'm finding the areas to the left. Those are the two z-scores. I find the two areas to the left. To find the area in between, I subtract them. I get that answer right there. Estimate the IQRs. So we did a problem like this yesterday. So Q1 has 0.25. That is an area. So I'm looking at the area here and I'm going back out to find the z-score. So I get negative 0.67 for this one. Q3 has 0.75 to the left of it. I get positive 0.67. I've solved those ones, subtracted. There's my IQR. All right. Here we are. So with this particular section right here, I want to show you how to do these problems in the calculator, and I am basically taking this problem here from the warm-up. So that's why I said if you didn't do the warm-up, you're not going to be able to compare all the different methods here. So the calculator is going to replace the table pretty much. There's two calculator commands. If you're trying to find the area, the calculator command is normal CDF. It'll ask you for the lower bound of the area that you have shaded. It'll ask you for the upper bound of the area that you have shaded. It'll ask you for the mean. It'll ask you for the standard deviation. The score value, so if you want the z-score or you want the value that's on the x-axis, that command is inverse norm. It'll ask you for the area. We're going to just always say it's the area to the left. On these newer calculators, it doesn't have to be the area to the left, but if you have an older one at home, it needs to be the area to the left. So it's the area, comma, the mean, comma, the standard deviation. What work do you need to show? You're showing me the same stuff that I told you to show me yesterday. So all those little things there, we're doing the same thing. The only thing that's going to change here is that calculation part. So I'm going to be a little bit redundant here. So this is the exact same problem that you just did on the warm-up here. So again, I'm being redundant because I am showing you everything you would show me. So you would write down normal. There's the mean. There's the standard deviation. You would still draw your picture. So we want over 200. Okay. There's two ways. So I'm showing you the calculator. One way is to still find the z-score, but instead of using the table, I'm going to use the calculator. Then there's one way where we just don't find the z-score at all. So I think I'm going to show you, because I have the same problems as, so A, B, and C are the same thing as this B, C, and D in the warm-up. So I'm going to show you just this first column first, and then I'll come back and show you the calculator only. So you would still find the z-score just like we did on the warm-up. So right now everything kind of is still looking the same. Now on the warm-up, what you did is you had a z-score, so you went to your chart. So you had 0.5, you found this area right here, but then you had to do 1 minus that because you wanted the area to the left. Well, on the calculator, what I would do is basically what I've done is I've changed this problem. And I'm going to draw another bell-shaped curve here. You do not have to draw this one. I won't expect to see this one too. But basically what you've done here is you've taken that 200 and now you've changed the problem to be normally distributed with the mean of 0 and a standard deviation of 1. So you've changed it to be on the standard normal curve. So here, to find so I want to find the area. So I would use normal CDF. The lower bound of what's shaded here is 0.5. The upper bound is positive infinity. I'm going to show you how to do that in the calculator. And again, I've changed it to a z-score, so it's 0 and 1. So on your calculator, where it says vars, above the vars in blue it says distra, so that's distributions. So we hit second vars, there's my normal CDF. So again, my lower bound is 0.5. I can't type in affinity, so if you noticed I wrote E99. That's basically like 1 times 10 to the 99th. So we're going to hit second, comma. I want that E right there. I don't want alpha E, I want second comma. That's the scientific notation, 99. So again, I have 1 times 10 to the 99th. And the default values here will be 0 and 1. I hit paste. There's what I wrote there. There's the answer. I'm going to round these ones now to 4 decimal places. That was basically what I had in the table, so I'm going to round them to 4. So that's what we got in the table. Now I'm showing you how you can get the same answer in the calculator. And again, I would write the summary statement. I'm going to write it here in the middle because it's going to apply. So about 30.85% of adult women have cholesterol levels over 200. All right, like I said, I'm going to come back and show you this other one, but we're going to keep going here. So again, when I'm doing this one right here, pretty much I'm not going to rewrite this again. It's the same thing. I'm going to draw a new picture. It's the same problem as the warm-up. So 150, 170, shading in between there, converting it to a z-score. So this is nothing different from the warm-up. So again, I'm going to draw that other picture. Now you've switched the problem to be on the standard normal curve. That 170 is at negative 0.75. The 150 is negative 1.58. You're trying to find that area in between there now. So here, when we did it on the warm-up, you had to look that z-score up on the chart. Those z-scores, you found the area to the left, and then we had to subtract. Here, it's a little bit easier. Again, I have the z-scores. I am trying to find the area, so I use the normal CDF command. The lower bound of this shaded is negative 1.58. The upper bound is negative 0.75. Again, 0 and 1 because I've converted everything to that standard normal curve. So we hit that second vars. Normal CDF is number 2. Negative 1.58. negative 0.7501, paste. Again, I'm going to round that to 4 decimal places, as that's what it would have been rounded to on the chart. And again, I'm getting a slightly different answer just because I can be a little bit more exact here. But otherwise, it's the same. I would write the same summary statement. Again, I'm going to share this one. Okay. So, like I said, I'll come back here and do this in a second. And then I'm going to show you how to do C here. So, same thing here. All right, this one again, we need to find the 2 quartiles. So Q1 has 0.25 to the left of it. Q3 has, I'm just going to put the arrow up here, it has 0.75 to the left of it. I don't want to, I could shade again, but it's like I'm shading over what I'm shading. All right, and this particular one, you use the table to find those z-scores. So if I want to find the z-score for Q1, I have the area now, and I'm trying to find the score, so I'm going to use inverse norm. It'll ask me for my area, and then my mean and my standard deviation. So again, I go to that second bars, inverse norm. On these newer calculators, you can change where the area is. Again, I'm going to always do the area to the left because that's what it would be for the older calculators. So 0.2501. So that's why I didn't even write left, because I'm going to always assume that you just do the left. If you want to do the right or center, that's fine. You need to add that then for me. All right, I'm going to keep a couple more decimal places now. Because remember, I'm not done with this. I'll keep that 3rd decimal place. So I can get a little bit more of an accurate answer here. If I do the same thing for Q3, that's going to have an area to the left of 0.75. Again, remember it's symmetric. So again, I'll keep that extra decimal place there. Just as an FYI, so you could use, so if you wanted to do 0.25 and I did the area to the right, remember Q3 would have 0.25 to the right. So I would get that Q3 z-score. You can do that. Again, if you're going to switch it up on me, tell me that you switched it up. If you use the center option, then you need to give the area in the center. So in this case, 0.75 minus 0.25 is 0.5. So that'll give me both quartiles there. Again, I'm going to always just, my answers are always going to be to the left because that's what the old calculator or the old calculators do. So that's what you'll always see me is just do something to the left. And then at this point, it's really the same thing as the warm-up, but now I have that added number, that added decimal position there. So I can just get a slightly more exact answer here. So remember this one right here, I mean, I guess I don't have, normally I would just call them X, but we know that this is supposed to be Q1, and this one's going to be Q3. So this Q1 ends up being 204.2, no, that's Q3. Q1 ends up being 171.8 when you use the more exact answer. Q3 ends up being 204.2. So again, I can find the IQR by doing 204.2 minus the 171.8. and I get the 32.4. So the middle 50% is spread over 32.4 milligrams per deciliters. If you, again, you could, I wrote warm up the IQ. I'm going to write that. That's fine too. All right, so we get a slightly more exact answer because I can go out to more decimal places. All right. So some people would say that this method is probably the most preferred method for some teachers. The reasoning being that you are still calculating a z-score, so you're kind of always relating it back to that standard normal curve. The z-score is something that we'll see later on when we get into our significance tests. So the idea of a test statistic is very similar to the z-score. So then if you keep calculating it now, you'll remember how to do that. You know, we might as well use technology to find that answer because we have it, as opposed to using the tables. So some teachers would say that this method is the best approach for you because it kind of brings the best of both worlds. There is another option here where you don't have to calculate the z-score at all. I am fine if you want to do this option. Just don't forget what that z-score is and how you can always take any curve that's normally distributed and convert it back to that standard normal curve so we can solve those problems there. So if you wanted to do it this way, basically you're still going to have, this is still going to be the same. You don't have to calculate the z-score. So I'm not converting it. So my lower bound would be 200. I would use that E99 for positive infinity. But I'm not using 0 and 1 because I didn't convert it. I'd be using 188 and 24. So I'd have 200. Again, that E above the comma, 188 now, and 24. So again, you'll get the same answer as before, but you didn't have to calculate the z-score. The same thing down here for this one. Again, I'm not going to rewrite that because it's the same thing. You don't have to convert it. Lower bound is 150, upper bound is 170, 188, 24. Oops. Again, you're getting that same answer. Oh, this is like 995. So we're going to round it to that. Okay, so you're getting that same answer there, slightly more exact because I didn't even round. Here I had to round. I didn't round anything there. Okay. And then the same thing back here in this one. Q1 still has that 0.25 to the left of it. Q3 has that 0.75 to the left of it. So to find the Q1 value, I would just do inverse norm, 0.25, 188, 24. To find the Q3 value, it'll be inverse norm. Again, I'm always doing these with the area to the left. I just kind of keep that area to the left because that's how the table was. That's how the old calculators were, so I just kind of stay consistent there. So 0.25, 188, 24. I'm going to switch back to the left there. So there's my 171.812. I'm going to do the same thing for Q3. And again, I could take this number minus that number and my IQR get a slightly more. I'm going to round it to 2 decimal places. Exact answer, just because I didn't have to round anything. Just one thing I didn't mention here. So then you'd still have a summary statement like you just I put in the middle there. So everything that you write is still the same. So this method saves you the calculation of the z-score. If this is positive infinity, we're using that E99. Again, that's scientific notation, so it's like 1 times 10 to the 99th. If you wanted to use, if you need to go in the opposite direction and go to negative infinity, remember this normal distribution curve extends forever in both directions. So negative infinity, I would just use a really small number, really small number. So I just switched that to negative E99. If you noticed, I think the first on the calculator, that was like kind of the lower bound default. You can put the 1 there if you want, but you don't need to. You can just do negative E99. So that would be negative infinity. So this last one right here, I'll do both ways at the same time. So again, we have the same notation, so I'm not going to keep rewriting that. We want to figure out the highest 15%. So this is 0.15, so then the area to the left is 0.85. So if I was doing it with the z-score, I would find the z-score first. So to find the z-score, I want to figure out the z-score that has 0.85 to the left of it. So I would go to inverse, oh, I hate when I do that. Inverse norm, 0.85, 0, 1, left, paste. So this z-score right here, so 1.036 has 85% to the left of it. I would take that z-score. It's 188 over 24. Basically, I'm just going to take that answer times 24 plus the 188. So 212. So 15% of the cholesterol levels are higher than 212.87 milligrams per deciliter. If you wanted to do it this way and not do that z-score calculation, again, same picture. I have 0.85. This right here was the 0.15. I want to find the score. So I'm not going to call it a z-score now. I can just call it x if you want to call it anything. Inverse norm, 0.85. I did not convert it, so I have to use the 188 and 24. So remember, if you're using that 0 and 1, that means you have a standard normal distribution with the mean of 0 and a standard deviation of 1. And then there's the answer. Why did I keep 3 instead of 2? No idea, just because I did. All right. So again, you can pick either way. There are going to be times, so like that last problem that we did here when we had to find the mean, there's times where you are going to still have to use this method here because you can't use inverse norm if you don't have a mean. So there will be times that you will have to use this method or have to use the charts. Like you'll have to still calculate a z-score, but a lot of the problems you can always just go straight to calculator only. Again, that z-score idea doesn't go away. We're going to see it again later on, but go ahead and finish these problems right here. If you are running short on time, I'm going to show you all the answers, but if you're running short on time, just to kind of like make sure you practice, you know, a good, decent number of them. You could skip A if you were short on time. B, C, and D would be good ones to do. And then E and F would be good ones to do if you were short on time. So you could skip A and 3 there if you're short on time. If you are not short on time, I would encourage you to do all the practice. I would tell you right now to pause the video because I'm going to show the answers for all of these. So for the first one, again, don't forget to write down that. There's my picture. You don't have to worry about writing that. That is what I'm finding. I'm finding the probability that it's over 100. That's why I wrote it like that. I did not convert it here. There's my answer. So approximately 13%, or no, sorry, 0.13% of his fastballs will travel over 100. This one right here, less than 90. Again, I'm finding the probability less than 90. You do not have to write that. I just wrote it. There's my negative infinity to 90, 94.2, approximately 2.28%. Again, I didn't rewrite that. Same problem. I wrote it again. You don't have to keep rewriting it. There's my new picture. I want to find the probability that I'm between these values right here. Approximately 38.29%. The 30th percentile, so remember that means he's better than 38%, I'm sorry, better than 30%, so you want to figure out what has an area 0.3 to the left. I'm trying to find the score. They give me the area, so I'm using inverse norm now. So that's the 93. Low outliers. So to figure out the low outliers, I'm going to have to do the Q1 minus 1.5 times the IQR. So I need to find my two IQRs, or sorry, I need to find my two quartiles. Then I find my IQR, and then I do the Q1 minus the 1.5 times the IQR, so anything less than 88.6 miles per hour is considered a low outlier. And like I said, this is one of those ones where you have to use that Z-score formula. So I know that 40% are going less than 90 miles per hour. I also know a Z-score of negative 0.2533 has 40% to the left of it. So there's the Z-score, the value minus the mean, divided by standard deviation, so there's my standard deviation. Same thing down here. This one right here, the third quartile is this. This is the third quartile for the standard normal curve. My Z-score formula relates the two. There's the Z-score value, there's the value, mean. I need to find the standard deviation. Okay? One thing I just did not mention here, I don't think I said it yesterday. In these particular problems, in any of these normal distribution problems, when we are finding the probability of being like, I don't know, let's say we want to find the probability that we're greater than 120. If I wanted this number right here, the probability of being greater than 120 is equal to the probability of being greater than or equal to 120. Those answers are equal to each other. The reason why is because I'm finding area, and so the probability of being equal to 120 is going to be 0 because there's no area of a line. So those answers end up being the same in the normal distribution. It's a continuous distribution, so those answers always end up being the same. So if a problem says, you know, greater than or greater than or equal to, you're still going to do it the same way, so you don't have to worry about distinguishing the difference between those. Okay, so you can replay the video if you need to. Tomorrow, on Friday when I'm back, or the next day, we'll do the warm-ups, so I'll be able to see, you know, if you got it or not, and we can answer any questions then. All right, have